In these notes, we're going to go through the perimeter and area of similar figures and how that ratio changes versus just the size of the figure. So a couple things. We need to go through some notes on just our ratios again and similar figures and just proportions. So if two polygons are similar, then the ratio of any two pairs of corresponding lengths are going to be equal. So we need to remember what a ratio is. So ratio is a simplified fraction that is used to compare sizes of similar figures. So a ratio may not be the actual measurements, but it's used to describe how the figures are related in size. A ratio represents the reduced form, since you always want to reduce it, of the geometric measurements. So in other words, that's about the corresponding lengths or the sides. If we have two polygons that are similar, the ratio of their perimeters will be equal to the ratio of the corresponding side lengths. So the ratios that we've dealt with before with the side lengths is going to be the exact same ratio as the perimeters. So the ratios are equal for the perimeters versus the sides. All right, so for the areas, how that's a little different is if we have two polygons that are similar with the lengths of corresponding sides in a ratio of A to B. So that's what the sides are. And if you look at your picture down here, the red to the blue is my A to B. Then the question is, how does that change if it's the ratio of the areas? And what we are going to do is square them. So it's A squared dot dot and then our B squared. So the ratio of their areas can be found by squaring the ratio of their lengths or their perimeters, depending what they are, because remember they are equal to each other. In our first example, this is used to show why it is squared. So if we see our two figures over on the side, we have two rectangles, and if you notice, remember our rectangles are opposite sides are going to be congruent. So we can add in our different measurements on here. That's a T. So if we want to find the ratio of the perimeters, in this figure we're going to do the ratio of the big figure, so that'd be my blue over the red. So the ratio of the perimeter, we need to go through and add up the different sides for that large figure. So we're going to be taking our 2T plus 3T plus 2T plus 3T on top. And that gives us, let's see, 5, 6, 7, 8, 9, 10. So 10T. On the bottom, if we add up our red figure, so 2 plus 3 plus 2 plus 3, we get 10. And if we reduce this, the 10s are going to cancel, and we're left with just the T. So if we go to the ratio of the areas, we want to multiply for the area of a rectangle, so 2T times 3T. Over my red figure is 2 times 3. So when I multiply this, I get 6T squared, and on the bottom I just get my 6. My 6's cancel, and this equals T squared. So if you notice, the ratio of the area and how it differs from the ratio of the perimeters, it is squared. So basically it shows us the exact same thing that we had mentioned on the previous slide. For number 2, you are given that the two triangles are similar to each other, and it tells you the order. So you can see that BC is right here. So BC corresponds with side EF. So my 8 corresponds with my 12. And I need to find the ratio of the red to blue of the perimeters. So that means that my red numbers will be on top, my blue numbers will be on the bottom. We need to remember that our ratio of the perimeters is the same as the ratio of our sides. So if I have the ratio of the sides, that's the same exact answer as the ratio of my perimeters. So I need my red numbers on top, so that would be my 8. My blue number on the bottom, and that would be my 12, and I always need to reduce. So I can divide both of those by 4, so I end up with, let's see, 2 over 3, or sometimes you might see it written as 2, 3 side by side like that. So next we want to take that ratio, So take our ratio of 2 to 3, and now I want to find the ratio of the areas. So if you remember, we need to square both of the numbers to find the ratio of the area. So I'm going to take 2 squared and 3 squared. So that gives me 4 over 9. And now that is my ratio of the areas. And again, we can write that side by side as well. So 4, 9, like that. On this chart, you're going to see something like this in your homework in the textbook, where we need to fill in the missing boxes given the different ratios. So in this first one, we see that the corresponding side length ratio is 2 to 3. And if you remember, the ratio of our perimeters is going to be the same as that same number. So 2 to 3. The ratios of the area, remember, we need to square both of those numbers. So I need to squeeze 2 squared in there and 3 squared. So I'm going to have 4 to 9 is going to be my answer. So in the next one, we start with 3 to 5. And again, the ratio of the perimeters is the same as the ratio of the sides. Those can be interchangeable. So I'm just going to leave it as 3 to 5. But if I want to square it for the area, I will have 9 and then 25. All right, so what happens if we are given the area ratio? Well, the opposite of squaring it is, to get here, we need to take the square root of those numbers. So the square root of 36 and the square root of 25 gives me a 6. 5 is my ratio. We know that from this ratio of the perimeters to the ratio of the sides that it is the same ratio, so this also will be 6 to 5. So remember that the ratio of the side lengths, that these are the same ratio, but if we start with one of the sides or the ratio of the perimeter, that we need to square the ratio. So if you're going to be getting the area, just remember you have to square those numbers before you solve anything. So in these two questions, these two polygons are similar. We need to find the ratio of the shaded to unshaded. So that means that the shaded will be on top. The unshaded will be on the bottom of our ratio. And we need to find that of the perimeters and of the areas. Then we need to find the unknown area. So let's first find the ratio of our different pieces. So I set it up on my paper, the ratio of the sides. So we want to do the shaded, so that'd be my 2, to the unshaded, and I need to reduce this. So this gives me a 1 to 4. The ratio of the perimeter, remember, is the same, so it's also going to be 1 to 4. The ratio of our area, we need to square both of those numbers. That'd be 1 squared and 4 squared. And that comes down to 1 squared is 1, 4 squared is 16. So there's our ratio of our area. So next we need to use this area. It's the ratio of our area. So 1 over 16, we need to use that ratio along with our area of the first shape, and then our x would be the area of our second shape, since we do not know what that is yet. We need to use that to set up a proportion. Okay, so I'd like you to push pause and go ahead and write out what I just said. So use the ratio of the area and the given area number to set up a proportion and solve for x. So that's what we are going to do next. So let's go ahead and do that. So if we have our ratio for our area is 1 over 16. Now remember, it was shaded on top, unshaded on the bottom. So that means on the top number needs to be a shaded number of our area. So that would be my 3 right here. And then our unshaded area we do not know, and that's our x. So now we need to cross multiply again. So 1 times x equals 3 times 16. So we get a 1x equals, and 3 times 16 is 48. So that means that my missing area is 48, and this is feet squared. All right, for our two trapezoids on the side, let's go ahead and set up our papers with our ratio of the sides, ratio of the perimeter, and ratio of the area. So now that we have that set up on our paper, now we can look at the corresponding sides. So the ratio of the sides, we're looking at our 9 and our 15, and we want these shaded on top, unshaded on the bottom. So we're going to have 9 over 15. When we reduce that, though, because we can divide both of those by 3, we get 3 out of 5. Now remember, the ratio of the perimeter is the same, so it's also 3 out of 5. Ratio of our area, we need to square them. So we need to do 3 squared and 5 squared. And that becomes 9 over 25. So then remember what we wrote here in purple. So use the ratio of that area. So that means my 9 out of the 25. I need to use that now with the area I was given. So that was my 225, but look at what shape it is. That is the unshaded, so that goes on bottom of my fraction. And what I need to find is the area of this other one. So my y will be the other part of my proportion. So now when we cross multiply, we're taking 9 times 225 equals my 25 times y. So 9 times 225 is 2025. We need to divide both sides by 25. So my y value will be 81. So the area that we are missing up there is 81, and this is inches squared. These 3 questions are just, or 4 questions, sorry, is really just a quick review of what that chart was showing, but just individual. So this time it gives us the ratio of the areas, and we need to find the ratio of the sides. So if you remember on our chart that it goes back to, we have to take the square root of what those areas are. So the square root of 9 and the square root of 25 gives us a 3 and a 5. Same thing for the next one. If we take the square root of 36, square root of 4, that gives us a 6 and then a 2. And one thing you want to notice in this one is you can reduce it. So always reduce your fraction. So this would be 3 to 1 actually in the end. For number 6, the ratio of the lengths of the corresponding sides of 2 similar triangles is 5 to 8. So it's the ratio of the sides is 5 to 8. And you want to find the ratio of the area. So you need to square the different numbers because we're finding what the area is. So we need to take our 5 squared and our 8 squared. So that'd be 25 to 64. And check if they reduce, but in this case they do not. So you just leave it that way. In number 7, they give you the ratio of the areas is 16 to 9, and you want to find the ratio of the sides. So it's really just like what we did up here. We need to take the square root of those numbers. So the square root of 16 and the square root of 9 gives us a 4 and a 3, and they do not reduce. We just leave it as 4 to 3. All right, these are the last 2 questions, and these will be like number 4 questions. In this case, we know that the 2 figures are similar, and they tell us the order. The way that we just need to figure out how we want to set up our ratios. So let's set up our ratio as the small figure over the big one. So that's just how we're going to set up in both of them. And you can just decide it really doesn't make a difference because in the end you're solving for a missing side, and as long as your ratios are the same set up all throughout it, that you can still get the same answer. So in this one, if you notice, we are given the 2 area numbers. So when we list out the ratios of the different pieces that we have, we need to start with the ratio of the area. So if we are doing small over big, we will have 168 over 378. And if you reduce that first, that gives us a 4 over 9. So if I want the ratio of the sides, remember we want to take the square root of those numbers. So square root of 4 and a square root of 9 will give us a 2 over 3 for the ratio of my sides. Now remember on the other ones, we need to use this ratio now of my sides to find one of the missing sides. The missing side that we need to find is right here, and we have the corresponding side that goes with it, and that is my 8. So that means that we need to use the ratio of the sides and the given side, that 8 up there, and we need to set up a proportion again to solve for my x. So we're starting with the ratio of the sides. That's my 2 to 3. And remember, it is the small over the big up here. All right, so with my 8 and my x, 8 comes from the small, so that goes on top. My x comes from the big, and that's on the bottom. So again, we need to cross multiply. So 3 times 8 equals my 2 times x. So we get 24 equals 2x. So when I divide by 2, my x is equal to 12. So that means that my xy, or my segment xy, sorry about that, So segment XY is equal to 12, and this will be centimeters. All right, so for my next figure, again, we need to start with the ratio of the areas, since that's the two numbers that we do have, and then move to the ratio of the sides. So for this question, we have the two areas, and the small is 15. The big is the 135. So if I reduce that, that gives us a 1/9 for that area ratio. So remember, the ratio of the sides, we need to take the square root of that. So the square root of 1 and the square root of 9, and we get 1/3. Now remember, we need to follow the part I have written in red again, or purple right here. We need to use that ratio, so that 1/3 in my proportion. And then I need to use this 15, and my corresponding side would be my x right here. And remember, it's the small over the big, so the x is from the small one, big is my 15. And now we can cross multiply to find what that missing side is. So 1 times 15 equals 3 times my x, so I get 15 equals 3x, divide by 3, and we will get a 5. So that means that my segment XY is equal to 5, and this is in inches this time.